Debye model. Okay, we're discussing Debye model for 3D solid. Debye model. Okay, or for 3D crystal. Okay, and we have seen, and we have also calculated the Debye frequency. Okay, so what is the difference between a classical model, Einstein model, and Debye model? Okay, in classical model, we said the energy is distributed in among the your degree of freedoms, and we have seen for harmonic oscillator there are 2 degree of freedoms. Why there are 2 degree of freedoms? Because you have 2 independent variable. If I write the kinetic energy of a harmonic oscillator, okay, I have kinetic energy plus potential energy, p square by 2m plus half kx square. So if I require only one variable, then degree of freedom will be 1. Okay, suppose if there is a my particle is moving only x direction, okay, then degree of freedom is 1. Okay, if it is moving in xy plane, then degree of freedom is 2, and if it's moving xyz, then degree of freedom is 3, because 3 variables are varying. Okay, similarly if you see harmonic oscillator, the harmonic oscillator, in order to define a state of harmonic oscillator, okay, I need x and px both variables. Okay, a harmonic oscillator state is defined by what? X and px. So it has a 2 variables, that's why it is a 2 degree of freedom. Okay, so 2 degree of freedom, and 1 degree of freedom, the energy is half kT. So half kT plus half kT, so total 1 kT. That is the total energy of harmonic oscillator. Okay, and we have seen Einstein model. Einstein model, what Einstein suggested? So Einstein suggested that all the atoms are vibrating, okay, with a single frequency, okay, in the crystal, and we have used Einstein model to calculate energy, which gives explanation which can able to explain the high temperature behavior of specific heat, but the low temperature behavior. Okay, Einstein model suggests that specific heat varies as the exponential decreases exponentially, which is faster than what we observe experimentally, which is t cube. Okay, now we are trying seeing Debye model, how Debye model can explain this exponential curve of specific heat. Okay, so for that, what we have done, we have written Debye model, we have written the density of states. Okay, gk dk. Okay, 3D phonons, 3D density of phonons. Okay, density of phonon states, 3-dimensional density of k state or phonon states.
Sir,
Ah,
sir, from this person only statement-based question may ask.
what you mean?
Sir, from this two model, that is Einstein model and Debye model, they can ask only statement-based question.
No, they will ask you, no, this like I'm calculating for 3D. Okay, 3D states, 3D, what is the specific heat to specific heat. Similarly, they can ask, and Debye frequency, they can ask what is the Debye frequency in 2D case, 1D case. Okay, and now we are assuming that dispersion relations are linear. Okay, like omega equals to omega v naught k. They may give some other some other dispersion relation. Okay, so you should know what is the methodology, what is the method we are following. Okay, and based on method followed, they can ask same questions. Okay, but we are using, and they may a little bit do some modification in the expressions. Okay,
Okay, sir.
so this is the gk dk what we are writing. Okay, gk dk is what, in 3 dimension. Okay, so you may be remembering gk dk is nothing. Okay, so gk dk v upon 2 pi. Okay, v upon 2 pi square k square dk. Okay, and in this particular case we have been given the relation between omega and v naught k as this one. Yes,
Here K was number of modes, no?
k was k states. The k is wave vector. K is wave vector. Okay, and each k value is represented in mode. Okay, and then you have to see that is in 1 dimension. Then you have to see the polarization also. Okay, like 3D we have 3 branches, so number of mode will be 3 times what was in 1D. Okay, so and the relation was given V naught K. Okay, here we are assuming, okay, we are assuming this one 3 V naught square equal to VL square plus 1 2 VT square, because we have 3D solid, okay, 3D monoatomic solid. So as I told you, there are 3 branches, okay, and each branch has a different velocity, but we are taking a average of this one. Okay, we are assuming we are taking these both are same, and we are taking one kind of average of these velocities. Okay, so now this is the relation. Okay, so I can write g omega d omega. Okay, so we have solved this one last time also, which
Sir,
came
where we gonna use this 3D monatomic solid, or you have given for knowledge?
3. What you saying?
So this 3D monatomic equation you have given, na?
But 3D, every crystal is 3D, na?
No, sir. We are going to use here, or you
Yeah,
have given that.
yeah, obviously here only, na? This is 3D crystal, na? 3D crystal, and it is a monatomic crystal. Okay, like silver, diamond, gold crystals, whichever same type of atoms. Okay, so I'm using that type of this solid. Okay, so here number of atoms we have monatomic solid. Okay, and we have to see also in the perimeter cell how many atoms are there, in unit cell how many atoms are there. Okay, so here I'm taking example of monatomic solid. Okay, so now if it is 3D crystal and monoatomic solid, okay, in that case what will become here, and the number of branches will be how many? How many branches will be there? 3. Okay, so the total model will be total modes will be how much? G omega d omega 3b. Okay, and we know the total modes g omega d omega, okay, from 0 to Debye frequency should be equal to 3n. Okay, number of modes should be equal to number of atoms. Okay, but this is we have 3 branches, so we multiply by 3. Okay, so this should be equal to this one, and after that we solving this one. Yesterday also we have calculated next last class the Debye frequency. Okay, and Debye frequency came out, okay, 6 pi square n upon v, okay, 1 upon 3 v naught. Up to this we have solved. Okay, so BD, this is cutoff frequency, Debye frequency, and cube of this one give you all 6 pi square n upon v is the volume, and v naught, which is the velocity cube. Okay, so here also we can define what we can define h cut omega d. Okay, h cut omega d is equal to theta d t. Okay, where theta d is what? Theta d is Debye temperature. Theta d is Debye temperature. Now just carefully watch how I'm doing calculation. Same way I will do for 2D or 1D. Okay, I'm writing density of states, I'm writing modes, I'm calculating cutoff frequency. Okay, similar process I will use for 2D when I'll do for 2D and 1D case. Okay, so this is my Debye temperature. Okay, so here from here I can write what? Omega dq equals to what? Theta d t upon h cut. Okay, and cube of this one. Okay, and from here I can calculate the value of v naught cube. Okay, as v upon, okay, you have v naught cube. Okay, this will be here 6 pi square come down to 6 pi square n. Okay, and theta d t upon h cut cube. So you should remember this notation also, this expression also. So now my aim is to calculate total energy. Okay, the mode I know. Okay, I need to calculate total energy. Once I know total energy, I can differentiate in high temperature range and low temperature range, and I can get what is the specific heat. Okay, so now let me write the total energy expression. Okay, total energy is what? 0 to omega d. Okay, average energy E omega G omega d omega. Okay, and we know the average energy for frequency of phonon. Okay, average energy of phonon for given frequency, if we calculated from Einstein model, hq e h cut omega kbt or kt, whatever you want, kbt minus 1, and g omega d omega just now we have calculated. Okay, g omega d omega is what? Nothing, 3 b 2 pi square. Okay, omega square v naught cube. Okay, d omega. But this is very simple expression. Okay, all constant will come out. So 3 v 2 pi square. Okay, v naught q will come out. V naught q will come out, and plus h cut will also come out, h cut. Okay, and the expression you will be having what? 0 vd omega q e h cut omega t kbt minus 1 d omega. Okay, okay, now just you can, what you can do, you can put the value of vq v naught here. Okay, once you put the value of v naught cube here, okay, you can simplify further this expression. Okay, so my u will be, okay, 3 v 2 pi square. Okay, h cut v naught q value if I put here. Okay, so that will be v. Okay, v, and this will be, this will go up 6 pi square n. Okay, and this will become opposite, this become 1 by v cube, so this become h cut cube. Okay, h cut cube upon theta d t power q. Okay, so this constant become this way. Now you can calculate pi square cancel, v cancel. Okay, so now what we'll having, so and this integration into integration है ही है 0 vd what you can write vd. Okay, vd instead of vd you can write what in terms of theta d. So okay, let it be here vd only. Okay, vd here will change later. So you have a vd here. Okay, and you have v cube omega cube e h cut omega kbt minus 1 d omega. Okay, now just solve this one. So you have, now just put e h cut omega kbt as x. Okay, so what you can write if you put this one. Okay, so this will be u. Okay, I have 3 upon 2. Okay, h cut cube h cut, and so here we have 3 cancel na, so 9. So I have 9 h cut. Okay, and 9 and h cut, 9 and h cut cancel नहीं हुआ था क्या? जस्ट चेक करो कितना.
नहीं सर.
अच्छा, तो ऐसे ऐसे रहने दो, कोई नहीं, ऐसे रहने दो. ओके, सो h cut should cancel ना. ये मैंने यहाँ पे उल्टा लिखा है क्या, और इज करेक्ट? थीटा d h cut upon theta d is correct. Okay, let it be there. So 3 9 h cut. Okay, 9 h cut, and we have h cut cube
h cut by 4 आ रहा है.
हाँ,
h cut by 4.
h cut by 4 कौन सा है यार?
h cut by 3 into h cut ना, h cut
हाँ
by
हाँ
4.
वो तो 4 हो जाएगा, ठीक है वो हो जाएगा, वो तो 4 हो जाएगा, नीचे तो यही है ना, बाकी तो ठीक है, just check the calculation once ना. So now I'm putting this one x, okay, so this become now, if you put vd, this become xd is equal to h cut omega d upon kbt upon x, and h cut upon kbt I can write uh, this one as a theta d, okay, so this become h cut omega kbt I can theta d, so this limit become theta d upon t, okay, and this become e power x minus 1, okay, and omega cube will be what, x cube, and kbt x cube, omega will be x cube, and kbt upon h cut power cube, okay, power cube, and if you put d omega, so dx equal to d omega will be, so this become kbt h, this power 4 into dx. Now it is correct, okay. Now if you solve further, now powers will cancel, you will see this will be will come as a simplified expression, so 9n, okay. Now you see here we have power 4 and here power 4, so we have h cut 4, and here we have theta d t cube, okay. And what is coming from this expression is coming kb4, okay, t4, and h cut 4, and this expression here remaining as we have having x cube ex minus 1 dx, okay. Okay. हाँ KB should cancel. KB should cancel ना. There's some why I'm writing KB here. Here KB is not there ना. हाँ here is coming KB. हाँ बोलिए.
सर यहाँ पे आपने जो ओमेगा डी था उसको जो आपने पहले एक्सप्रेशन लिया उससे चेंज कर दिया ना.
हाँ. Okay. Just check is here. KBT upon h cut. KBT upon h cut. Okay. So omega q will come and d omega. So KBT h upon 4 should come. Okay. This KB 1 KB was there na. I forgot 1 KB was should be there. Is KB was there? KBQ was there. You were just copying. Okay. Nobody helping me. Okay. So h cut new do KB. So when I'm putting here.
सर तो
हाँ.
यहाँ पे लिमिट में अगर आपने ओमेगा डी लिया है तो थीटा डी टी बाई एच कट आना चाहिए ना.
नहीं ओमेगा डी को हमने यहाँ के ओमेगा डी लेंगे तो एक्स क्या हो जाएगा, एक्स हो जाएगा एच कट ओमेगा डी बाई केबीटी ना.
हाँ.
फिर मैंने जो एच कट ये इसको मैंने रख दिया ना थीटा डी. भी लिमिट में क्या आएगा, लिमिट में तो आएगा एक्स टी, एच कट ये आएगा, ये लिमिट ये हो जाएगा, ठीक है.
हाँ.
और एच कट ओमेगा डी अपन केबीटी को मैंने थीटा डी लिख दिया है, थीटा डी टी, ठीक है. Okay, so I'm getting here some KBs. I'm getting more. It is KB should cut. You people check where mistake happen of KB. Okay, so this KB to KB was correct. This is e power x minus correct. Okay, and when I write the expression for V naught cube. Okay, in the case of V naught cube, does we have KB? Okay, V naught cube.
Sir, when we change the limit na, at that time something means factor will also change ना. d omega से हम dx को जब move कर रहे हैं.
हाँ तो 4 इसको मैंने ऐड कर दिया ना, एक ऐड कर दिया ना मैंने इसमें. एक ऐड कर दिया मैंने, ठीक है. ओके देखते हैं क्या हो रहा है. सो नाउ दिस आई एम गेटिंग 9 एच कट कैंसिल हो गया, पावर भी कैंसिल हो गया, टी क्यूब टी, सो 9 एन. ओके, we have KB4, we have T theta D cube. Okay, we have now x cube EX minus 1 theta D power T. Okay, this expression I'm getting. Now we have to solve this for low temperature limit and high temperature limit. Okay, and somewhere this K should cancel 3. This should some KB should cancel. I should have only 1 KB. I don't know where we missed this one. Just let me check. Okay.
Sir,
Hmm.
the final expression limits 0 to theta d by t, na?
हाँ theta d by t 0 to theta d by t 0 to theta d by t. Just check it. He should only come 1 kb should come. I don't know why it's coming kb4. Some should there should be some they should cut somewhere. Power should be cancelled somewhere. Okay, theta d. Okay, and somewhere when we write the expression for v naught cube. Okay, so we were having what vd cube. Vd cube we having 6 pi square and upon v naught cube. Okay, now when I'm writing this vd cube, okay, so vd cube should come what? Vd cube should come h cut vd equal to kb theta d. Okay, so kb theta d, so this should come kb cube theta d cube and h cut. Yes, kb cube was there na. Okay, and this was 6 pi square and upon v naught cube. Okay, so when I write value of 1 upon v naught cube, okay, so when I cube, so kbq should come down. Here some kbq are missing here, kbq. Okay, kbq are missing here some, so this will come your only kb. Just check it, here only will come kb. Okay, kb
बे फ्रीक्वेंसी क्या सब्स्टिट्यूट किए हैं
किसमें?
अभी अपने जो दिखा है ना उसमें डीबे फ्रीक्वेंसी क्या आती है मतलब एक्सप्रेशन क्या आता है सब्स्टिट्यूट करने
बी
के लिए
सब्स्टिट्यूट का एक्सप्रेशन ये है h कट ओमेगा d इक्वल टू kb थीटा d. बी क्या टेम्परेचर है ना, ये भी एनर्जी है, ये भी एनर्जी है, तो h कट u d इक्वल टू kt is temperature, t is temperature, here is d by temperature. ओके, वो एक्सप्रेशन में बस kb हमने लिखा नहीं है उसमें, चेक करना उसको एक बार. ओके, सो नाउ दिस एक्सप्रेशन विल कम t upon theta d cube. Okay, now let us solve this expression for low temperature and high temperature. Okay, solve this for low temperature and high temperature. Something mistake, एक और mistake है, temperature की mistake भी आती है. T4 coming here. Okay, T4 is coming.
हमने जो इनिशियल कंसीडरेशन किए हैं ना इनिशियल फॉर्मूले
Okay, let me do it again. Okay, some mistake is there. Now you have to check carefully what I'm doing. Okay, just okay. Now what we are doing? Okay, we are starting out from here. Okay, we have omega d cube. Okay, we have 6 pi square and upon v naught cube. Okay, now just I'm putting h nu d is your kb theta d. Okay, so from here omega d will come what?
Sir,
kb.
here only we have taken kbt के theta d sorry kbt की जगह में t ले लिया था.
यहाँ पे
हाँ सर.
हाँ दैट मिस्टेक. हाँ इस अभी तो पावर कैंसिल हो रहा है, तो दिस kbt theta d upon h cut. Okay, this expression I should use. Okay, so now my v naught q will be what? My v naught q will be, okay, my here I will be kbd theta d upon h cut. This cube should equal 6 pi square and upon v is a velocity v naught q. Okay, and from here I should get v naught q value as kb theta d upon h cut cube. Okay, and volume upon 6 pi square n. Okay, now just solve it. Just note down these values, v naught k value. Okay, now if I write the total energy, okay, so total energy was how much? Total energy was E equals to was E omega, okay, and G omega or D omega, this one 0 to WD. Okay, so let us 0 to WD This is h cut omega E h cut omega kBt minus 1. Okay, and g omega d omega का वैल्यू कितना था 3v upon 2 pi square. क्या था वैल्यू 3v upon 2 pi square. Then what is the value?
Omega square d omega by v naught cube.
Yes, correct.
V naught cube. Okay, now just if you solve further here, okay, so you have 3v 2 pi square. Okay, and h cut v naught cube here, and inside you have vd. Okay, omega cube d omega cube e h cut omega kbt minus 1. Okay, now put the value of here, so you get e equals to 3v 2 pi square h cut. Okay, v naught cube 1 by v naught cube value I want. So 1 by v naught value will be here. This will be h cut 6 pi square, and okay, sorry, this will be 6 pi square n upon v. Okay, and this will be h cut kb theta d power cube. Okay, and then we have expression 0 to wd omega cube e h cut omega kbt minus 1 d omega. Okay, so we cancel, this cancel. Okay, so I'm getting pi square cancel, so I'm getting 9n. Good. Okay, 9n, and then pi square h here, one h here is there, and then h cube kb cube, yes, and theta d cube. Now it is correct. And this expression is what? The same expression what I'm writing here. Okay, now just put the limit what we done earlier. Okay, same way. So you put the limit. Okay, h cut omega upon kbt. If you put x, okay, so I'm getting here this energy E. I'm getting 9n h cut 4. Okay, kb cube theta d cube. Okay, into integration. Okay, this limit will become xd h cut omega d upon kbt. Okay, and omega q will come kb t upon h cut. Okay, and d omega, so this x cube dx and ex minus 1. Okay, and if you solve this one, 9n h cut 4 kb cube theta d cube. Okay, and here I get kb4 t4 and h cut 4 x cube ex minus 1 dx 0 h cut omega d upon kbt. Okay, you people do yourself. Okay, calculations, simple calculations. So now we can get a simple expression. So I get e. Okay, this is the final expression you have to remember. So now h4 cancel, kb cancel. Okay, so now I have a 9n. Okay, kb t4 theta d cube, and this I have a 0, and this here h nu d upon kb I can write theta d upon t. Okay, so this will be 0 theta d upon t x cube ex minus 1 dx. Okay, this is the correct expression. Okay, are you people getting this expression?
Yes, sir.
Okay,
Yes.
now this just you to apply low temperature limit and high temperature limit. So first apply high temperature. This is energy, so apply high temperature limit. High temperature limit. Okay, so if we apply high temperature limit, okay, so we have x equals to h cut omega upon kBt. Okay, if it t is high, okay, then this expression x will be less than 1. Okay, in that case I can write ex minus 1 equal to 1 plus x minus 1 cancel, so I can write ex minus 1 x is equal to x here. So in that case my energy will be what? E 9 kBt for theta d cube 0 theta d by t. Okay, and this become now x. Okay, so this become x square dx. Okay, and if I open this one, 9 kb t4 theta d cube into x cube upon 3. Okay, that means theta d cube, okay, upon t upon 3. Theta d cancel, 3 cancel, 3 and power cancel, t cube. So I got the energy what? 3 n k b t cube. X theta, sorry, t only t, this is t cube. So only I got energy 3 n kBt. That is the well-known expression of energy. Okay, now you want specific heat. Okay, so specific heat what? Just del E upon del T or del U upon del T, temperature, constant volume. So you what you'll get 3 n kb, which is equal to what? If you take if n is a Avogadro number, if you're taking molar specific heat, if you're taking Cp molar,
3R.
3 Na kb equal to 3R. So that answer we should get. Okay, so it is very simple. Now high temperature, this model also saying the specific heat is equal to 3R. Okay, now I am done for 3D crystal. If you do 2D, you get 2 nkBt here. Okay, if you do 1D, you get one and you will get nkBt here, and just you to differentiate. So high temperature, you'll get this kind of expression. Okay, so this is correct. Now same thing you have to do for low temperature limit. This integration you have to solve for low temperature limit. Okay, so if you solve this for low temperature limit, T is very low, so this limit will become infinite. That's it. Okay, and then you have to solve for low temperature limit. Okay, please note down this expression so I can do further.
Sir, please tell how we are going to solve for low temperature.
So low temperature, T is low, so this limit will become infinite. Okay, now just we solve this for low temperature. Okay, for low
Sir,
temperature.
in this chapter, these final expressions are important, na?
Final expression. No, the method is important. How are we doing? How we are doing calculations? These steps are important. Okay, how we are getting total energy, then we are differentiating, how we are applying limits. Okay, so if you know one, then you can know all. So at least one expression, one process you should know. What the steps I'm following. Okay, now just I'm doing 3D. Now 2D and 1D you have to do yourself. Okay, I will just ask you and you to do. Okay, you tell me how you are doing. So now for low temperature limit, okay, your theta d, which T is low, become greater than 1. Okay, so I can put this limit tends to in theta d, low temperature T tends to 0. This become almost, this tends to infinite. Okay, so I'll get what? E equals to 9, okay, k b t4 theta d cube. Okay, and this becomes 0 to infinite x cube ex minus 1 dx. Okay, and this value, okay, what is the value of this integration? What is the value of this integration? If you know this value of this integration, then it is solved. Okay. Now just solve this one. You'll get E. Now the value of integration 0 to infinite. Okay, x cube ex minus 1 dx, and this integration, if you solve by contour integration, how much it should come? It should come pi by 4 upon 15. Have you seen this integration before?
No, sir.
This integration used many places. Okay, when we are doing Planck distribution law, your black body radiation, then also we require this thing. Okay, so by you can solve by contour integration and you get the value. Just put the values here and you have the low temperature limit. So if you solve this one, okay, 9n kBT 4 upon theta d cube, okay, into what? Pi by 4 15. Okay, and this will come out E equals to 5 3 by 5 n kb pi 4 t4 power theta d cube. Okay, now you want again specific heat. Okay, Cv molar. So what you can do, you can just differentiate this expression, del E upon del T. Okay, and if you differentiate this equation, okay, okay, so Cv will be what? Now write 3 upon 5. Instead of n, you write Na kb pi 4 t cube. Differentiate, it becomes 3t cube. So this becomes 9 t cube upon theta d
4t
cube.
cube.
तो 4t क्यूब है
So अरे तो 4 का डिफरेंशिएट करेंगे ना, तो आगे 3 नहीं था क्या?
तो 3 into 4 12 हो जाएगा ना.
हाँ सर 4 into t cube आएगा ना डिफरेंशिएशन.
तो 12 आएगा. अच्छा, तो 12/5. Okay, 12/5 t cube. Okay, very good. So this is my final answer. Okay, this is the answer.
सर हम यहाँ n को n क्यों लिख रहे हैं?
क्योंकि हम मान रहे हैं, हम मोलर स्पेसिफिकेट कैलकुलेट कर रहे हैं ना मोलर के लिए. तो एक मोलर में n कितना होगा? अवोगाद्रो नंबर.
ओके 1.
No, n is equal to na 6.20 6.02 10 to 23. N equal to na. B, if you want to, if you one mole of substance, then how many atoms will be there? Equal to Avogadro number.
ओके
If I say my substance is 1 mole, then the automatic number of atoms are equal to Avogadro number. Okay, so the Cv will be what? Cv will be 12 pi 4 by 5 Na kb t cube theta d cube, and Cv is proportional to what? T cube. And experimental curve also says should vary T cube. That means your Debye model is able to explain, okay, in both low temperature limit and high temperature limit, it can able to explain what? Your experimentally observed curve for specific heat. Okay. Now this we have done for 3D. Now you have to do for 2D exactly following same method what I did for this 3D. You have to do for 2D and 1D. Okay. So just start now for 2D. I hope everybody understood this expression. They got what I'm doing. Okay. Now we are done for 3D. Now exactly same processes you do for 2D. Okay. And tell me, I will give you the final expressions and what you're getting for 2D case. Okay. Now put the heading 2D crystal. Only you may require these final values. All the things are same. Okay. Now start doing yourself for 2D and 1D. Okay, at least do for 2D and 1D will be homework if we can't complete in time. Okay, just start from 2D case. Okay, so what is the first step? First step is write to density of state. Okay, so 2D density of state, 2D density of states. Okay, and 2D density of state is what? GK dk in 2D. This is equal to, I think, A upon 2 pi, okay, k dk. And you don't need to remember these things also. Okay, ये तो 1 minute में calculate हो जाएगा ना. If you know you want 2D, you want how many states are there, just take the circle and you know the volume of one state, 2 pi upon L square. So nk will be what? Number of state. Okay, you will be L square, that is A. Okay, you have 4 pi square. Okay, 4 pi square, you have 5 pi k square. Okay, now pi cancel, so you have nk equal to what? Nk equal to A upon 4 pi k square. Now you want gk is nothing, dnk upon dk. So if you differentiate this one, okay, you'll get upon A upon 2 pi, okay, k. And if you want gk dk, that will be simply A upon 2 pi k dk. So you will not need to remember. If you forgot, you can easily calculate. Are you getting what I'm saying? This is for 2D. For 3D also you can calculate 3D. There will be sphere and it will be 2 pi by L cube. So you can easily calculate this expression. Or only you know the what is the volume of k state in 1D, 2D, 3D. Okay. So that's no need to remember this one also. So now you have GK this one. Okay. Now what is the polarization factor? 2. Okay. Polarization factor. Now because of 2D only there will be 2 branches. Factor is equal to 2. So GK dk 2D will be what? 2A upon 2 pi. Okay, 2 to cancel. K dk. Just convert in frequency. G omega d omega. A upon pi. Okay. Now omega is equal to V naught K. So K will be what? V naught omega upon V naught. Similarly, dk will be what? D omega upon V naught. So you'll get what? A upon pi omega, okay, V naught square d omega. Simple. Now once you know this one, you can get that Debye frequency, okay, in 2D. So you know G omega d omega 0 to omega d should be equal to what? 2n. Okay. So if I put these values,
Sir, here in G omega d omega in right hand side, what you did? A by pi omega. Sir, this left hand side is G omega d omega equals to A by pi.
Omega upon V naught square.
So this above one is V naught. Okay.
It's V naught, na? Just use, that's why I'm telling you try yourself. If you copy, nothing is going to mind. Okay, I am writing, you're writing, copy, nothing is getting. Okay, I told you just follow what I've done in 3D. Exactly same process you follow for 2D. Okay, so now A upon pi upon V naught square. Okay, 0 to omega d. Okay, here I have omega d omega equals to 2n. So this become A upon pi. Okay, so this will give me omega d. If we solve this one, this will give me omega d square by 2. Okay, and we have 2n pi V naught square by A. So omega d square become what? 4n pi by a v naught square. Okay, from you can get here Debye frequency value omega d 4n pi a, okay, power half v naught. Okay, and we are going to require v naught value for simplification. So here you can calculate v naught value also. So v naught value is what? V naught value is, okay, or you can use v naught square value. V naught square value will be simply a upon 4n pi. Okay, a upon 4n pi omega d square. Just remember this expression. Now you need to calculate the now you also know omega d is equal to what? Omega d h cut omega d equals to kb theta d. Okay, so omega d will be what? Kb theta d upon h cut. Put this value here. So you got v naught square equal to a upon 4n pi. Okay, and this become kb theta d upon h cut ka square. Now just calculate the total energy. If you calculate now total energy U or E, that will be what? Omega d E omega G omega d omega. Okay, now this is 0 to omega d. E omega is again same h cut omega E h cut omega kbt minus 1. Okay, g omega d omega, just now you calculated. What is the value of g omega d omega? A upon what is
pi v naught square
A by
omega.
pi.
A by pi
Omega by omega.
v naught square omega.
Yes, sir.
Okay, d omega. That's it. Now solve it. This integration. Now, if you calculate the energy, U will be what? A upon pi. Okay, h cut also coming from here. A upon pi h cut. Okay, and v naught square. And this 0 omega d. Okay, this omega square d omega e h cut omega kbt minus 1. Okay, put the v naught square value from here. So a upon pi h cut 1 upon v naught square value will be what? 4n pi upon a. Okay, and h cut kb theta d square, same like symmetric, same expression come. Now it is 2d 0 omega d. Okay, omega square d omega e h cut omega kbt minus 1. Okay, a cancel. Okay, so now what you have? You have pi cancel. So you have 4n h cube. Okay, kb square theta d square and multiply by this integration. Now again you put what? H cut omega d kbt equals to x. Okay, so this total energy will become what? 4n h cut cube. Okay, kb square theta d cube into integration 0 to xd. If I put x this one, this becomes xd. Xd equal to what? H cut omega d kbt Okay, omega square will be your kbt upon h cut ka square x square ex minus 1, and d omega if you do, this is xd. Okay, and if you do d omega, that will come again, this become this t. Okay, and you become here dx.
थीटा डी स्क्वायर नहीं आएगा?
थीटा डी का स्क्वायर है, square. Okay, so if you solve this one, 4n h cut kb square theta d square. Okay, and if you put this is constant kb t h cut cube. Okay, and you have this one, and this again you can write theta d by t. Okay, theta d by t x square ex minus 1 dx. Okay, and if you solve this one here, you got same thing, you will 4 and kb hq cancel. Okay, so you got t cube and theta d square and plus the value of this one. Once you know the value of this integration, then it has become very simple. Now this is also we have to solve for high limit and low limit. Okay, so we have to solve this one for high temperature and low temperature limit. Okay, so let me solve this expression for high temperature. Okay, and for high temperature, okay, I can write Ex is equal to 1 plus x and Ex minus 1 is equal to approximately equals to x. Okay, at high temperature, what will become? H cut omega upon kbt is less than 1. Okay, so I can write which is equal to x. This is equal to x. So this is valid. So I can write my total energy 4n kb t cube theta d square. Okay, integration 0 theta d upon t x square, this become x dx, cancel, so u equals to 4n kb t cube theta d square, and this will come x square by 2, so theta d square half t square. Okay, theta d cancel, he become 2, power become cancel, so you get what? 2n kbt. In 3D you get 3n kbt, 2D you get 2n kbt, 1D you get only n kbt. Now you have to differentiate. Okay, so if you differentiate specific heat CV will be what? CV will be u. CV will be what? du upon dt. Okay, and that will give you what? 2n kb. And molar specific heat CV molar, give you 2 Na kb, that is 2R. For 3D 3R, 2D 2R, 1D 1R. Very easy, and procedure is same. Calculating pattern, calculating die density state, calculate the cutoff frequency, calculate the value of V0 in terms of cutoff frequency, write the expression for energy, then just put it values and solve this. Okay, so this is your high temperatures. High temperature, it is what we need. Same what we need. Okay, now we need to calculate this for what?
Low temperature.
Low temperature. Now put the here for low temperature or low temperature. Low temperature, this limit will tends to infinite. Okay. So this limit will be what? We have here x square ex minus 1 dx, and this become infinite. Okay. Now this value actually we should know. Okay. And this is also again standard integration. Okay. His value 0 to infinite x square ex minus 1 dx. Okay. It is actually equal to a zeta function. Okay. Zeta, this is equal to zeta. Okay, I'm giving direct value now. You can solve the contour integration, and the value of this integration is 2.40411. Okay, which is equal to what? This is equal to 2 zeta function. So zeta function 3. This is basically zeta function. Okay, and zeta rho 3 value is half of this one, 1.2. I think 1.202000205. Okay. And suppose even if you don't know that the value of this expression,
ये क्यूब तो दिख ही रहा है सर ऐसे भी.
अब वैसे भी दिख ही रहा है, और वैसे भी तुम इसको भी डिफरेंशिएट कर सकते हो भाई. इसको डिफरेंस कर सकते हो ना, इसको डिफरेंस कर सकते हो. ये तो कांस्टेंट ही है, आप इसको डिफरेंस कर ही सकते हो ना करने के लिए, करने के लिए. तो वो हो जाएगा. इस पूरे एक्सप्रेशन को अंदर ले जाओ, फिर डिफरेंशिएशन कर दो. पावर का अंदर जो जिसका जो 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 वेरिएबल है डिफरेंशिएट कर दो, और इसको एज इट इज ऐसा कैसा रख दो.
सर ये फंक्शन अपने कौन सा लिखा है? रूट
जीटा फंक्शन, जीटा function. Okay, put the values and give me the specific heat. Okay, so if I calculate the specific heat now, okay, the specific heat value मैं डायरेक्ट लिख रहा हूँ, तुमको बताना है, is coming as 20 T क्यूब आ रहा है ना, so 28.8492 10 kb T upon theta d square. ये आना चाहिए मेरा आंसर. बताओ आ रहा है तुम लोगों का?
932 आ रहा है.
क्या 28 आ रहा? 28 आ रहा, नहीं आ रहा? 28 पॉइंट समथिंग.
हाँ सर 28.849.
हाँ ठीक है, इतना करो बस. 28 इतना क्यों चले, इतना लिखो बस. 28.4 एन के बी टी अपॉन थीटा डी स्क्वायर. So this was for your 2D. Okay, now 1D तुमको अपने आप करना है. I am standing here. I will just give you the what you need, the value of that integration. Okay, and you have to tell me the final answer. Okay, now if you do for 1D, okay, you may require an integration called 0 to infinite e power x upon ex minus 1 dx, और इसकी वैल्यू होती है पाई स्क्वायर बाय 6. बाकी तो हाई टेम्परेचर में तो निकल जाएगा वैसे ही, लो टेम्परेचर पे तुमको यहाँ फंसेगा. पाई स्क्वायर 6. नाउ जस्ट कैलकुलेट the low temperature and high temperature values of specific heat for 1D. I'll come in 2 minutes. Now we have seen that in 3D we are getting CV T cube, and 2D we are getting what? CV equal to T square. So in 1D you get CV equals to proportional to T at low temperature. At high temperature you get CV equal to R. You're getting 3R in 3D, 2R in 2D, and 1D you'll get 1R. Okay. So that's very easy. Okay. Let me write the expressions. So if I write for high temperature and low temperature, okay. So for high temperature, okay, you will be what? You will be NA KBT, and CV will be what? NA KB. And for low temperature, you'll get U equals to N pi square by 6 N, okay, KB T square upon theta D, and you get CV equals to pi square upon 3 and KB T upon theta D. These expression you should get. So start from the beginning, what we are doing, writing density of states. Okay. So for 1D, okay, we know density of states, okay, GK DK is equal to what? L
L by
upon
pi dk.
L by pi dk. Very good. And now we know the dispersion relation V naught K. Okay. So G omega d omega will be L upon pi d omega upon V naught. Okay. Now G omega d omega equals to N. Okay. So this will give you L by pi 1 by V naught. Okay. D omega will be what? Omega d equals to N. So omega d will be what? N pi V naught upon L. Okay. And here we can get the V naught values also. And implies V naught will be your L omega d upon N pi. Okay. Now we need total energy 0 Vd E omega G omega d omega. 0 Vd E omega is h cut omega E h cut omega upon kbt minus 1 G omega d omega L upon pi d omega V naught. So U will be what? L upon pi h cut 0 omega d V upon V h cut kbt minus 1 d omega. So U will be what? L upon pi h cut V naught value is N upon pi L omega d. Okay. or omega d also we have to solve here. No? Omega d also we have to write in terms of theta d. So V naught will be what? L n pi, and this is what? H cut omega d equal to kb theta d. So this becomes kb theta d upon h cut. Okay. So this become L upon pi h cut. 1 upon V naught will be what? N pi upon L, okay, into h cut upon kb theta d plus this integration. And if I solve this one, I get u equals to L से L cancel, pi से pi cancel, okay. You have n h cut square and h cut square kb upon theta d, kb upon theta d, okay, and integration 0 omega d omega e h cut omega upon kbt minus 1 d omega, okay. Again put the limits, h cut omega kbt equals to x. So if you solve further, this will become n h cut square kb theta d, okay, and this limit will change to 0 xd h cut omega d kbt, okay, and then you can add theta d upon t, omega will be kbt upon h cut x d omega से आ जाएगा इधर से, फिर e omega this ex minus 1 dx. Okay, so you people do yourself, okay. सब same ही कर रहा हूँ, I'm repeating again, those nothing is there. And if you solve the expression for energy, I have n h cut square kb theta d, okay.
स्क्वायर कैसे आ गया?
कौन सा वाला?
kbt upon h cot वो इंटीग्रेशन के अंदर
ये वाला वैल्यू पुट किया ना, ओमेगा की वैल्यू kbt अपॉन h कट आएगा ना,
तो स्क्वायर नहीं होगा ना, सिर्फ
तो
kbt
फिर d ओमेगा भी करोगे, d ओमेगा फिर से क्या आएगा? dx kbt अपॉन h इंटू dx.
ठीक है सर.
लिमिट में आपने क्या किया है मतलब?
अरे भाई तुम एक ही चीज को अभी मैं अगर मैं यहाँ ओमेगा डी लिखूंगा तो मेरी लिमिट क्या हो जाएगी? ये हो जाएगी ना h कट ओमेगा डी बाय kbt. हाँ, तो थीटा डी अपॉन टी इज इक्वल टू h कट ओमेगा डी अपॉन kbt तो है. इसी को तो मैं लिखता हूँ, बार बार लिख रहा हूँ थीटा डी. समझ में आ रहा है अभी?
हाँ सर, क्लियर है.
तो क्या हो गया यहाँ से? kbt अपॉन h कट का स्क्वायर दिस बिकम 0 थीटा डी अपॉन t, ओके, x अपॉन ex माइनस 1 dx. h कट स्क्वायर कैंसिल हो गया, kb एक पावर कम कैंसिल हो जाएगा और t स्क्वायर बचेगा. सो आई हैव u इक्वल्स टू n kb t स्क्वायर थीटा डी, और ये इंटीग्रेशन था ही 0 थीटा डी बाय t x upon ex minus 1 dx. Now for high temperature limit, okay, if you solve for high temperature limit, you get u equals to n kbt square upon theta d, और इंटीग्रेशन सॉल्व करेंगे तो क्या है, ex minus 1 equals to x. So this integration will be simply dx. Okay, x is considered dx. That is mean theta d by t. This come as a theta d by t. Theta d cancel, t power cancel. So you got u equal to n kbt. Okay, and cv equals to n kb, and cv molar equals to na kb, and na kb is equal to r. Now just calculate low temperature limit. Low temperature limit, I have already given you the expression what you required. All of you getting or not getting what I'm doing here?
Yes, sir.
Getting the
Thanks, sir.
So now just supply low temperature limit here. Low temperature limit. Low temperature limit. T tends to 0. Okay, low temperature means what? T tends to 0. This tends to infinite. Okay. And expression.
square by 6.
So you will become what? You will become n kb t square upon theta d. This becomes 0 to infinite x upon ex minus 1 dx. You become what? n kbt t square theta d. इसका वैल्यू कितना है? What is the value of
Pi square by 6.
I square by 6?
Pi square by
Okay, so this become pi square by 6 n kb t square theta d. Okay, and cv is what? Cv is equal to del u upon del t. That is, you got pi square by 3 n kb t upon theta d. So you got cv proportional to t at low temperature. And this cv is what? Due to phonon. This is phonon contribution, not electronic contribution. What we are calculating now, phonon, the specific heat due to vibrations. Vibration means phonon. So whatever specific heat so far we have calculated in 1D, 2D, 3D, that is only because of phonons. Okay, not for electrons. We are getting phonon specific contribution to specific heat of due to phonon vibrations. Okay, so this was your specific heat in 1D, 2D, 3D. In exam you should know. The exam tomorrow we'll do some questions where you will see they have calculated this one. Debye frequency, ask Debye frequency in 1D. So those simple questions will come. Okay, what we have done, little bit modification can be there. Okay, so I'm stopping here. Any question? Okay.
No, sir.
Thank you.
sir.
Thank you.
Thank you, sir.
Yes.
जैसे सर हम लोग आइंस्टीन मॉडल में सर जब टेम्परेचर नीचे निकलता है तो उसका अपन ग्राफ प्लॉट करते हैं, तो अपनी इसमें जब अपनी लो टेम्परेचर के लिए टी क्यूब आ रहा है और टी स्क्वायर टी आ रहा है, तो सर उसको ग्राफिकली टेस्ट तो करेंगे?
हमको तो कल टी का वेरिएशन देखना है ना?
यस सर। ये
बाकी तो कांस्टेंट है सारे। थीटा डी जो होता है वो तो कांस्टेंट है गिवन मटेरियल के लिए। ओके, जैसे मैंने बताया था आइंस्टीन मटेरियल कांस्टेंट होता है। अभी मैंने क्या लिखा था, थीटा क्या होता है, थीटा डी क्या होता है, थीटा डी इज व्हाट, थीटा डी इज योर एच कट ओमेगा, क्या होता है एच कट ओमेगा डी बाय केबीटी। ओके, दिस थीटा, सो आर यू श्योर दिस इज थीटा, थीटा डी? The h cut omega d is what your
H cut omega
theta d
upon
theta
T
d.
is equal to theta d by T.
हाँ t कहाँ से आएगा? KT की टेम्परेचर का ये लिखा हुआ है ना. Okay.
ठीक कैंसिल हुआ तो वही होगा. हाँ सही है सर.
Okay. And theta d is what? Theta d is what your h cut omega d upon kb. Okay. And omega जो frequency है, that is we have already seen lattice, that is depends on your spring constant beta by m. Okay. So theta d is constant for given material. This constant is constant, and this is also we are taking a linear region. Okay. So that expression we can use, and we can calculate the theta d for every materials. Okay. So so can I stop here?
Yes,
सर
sir.
यहाँ टी स्क्वायर में मतलब पैराबोलिक नेचर आएगा ना ग्राफ का.
हाँ, मतलब वेरिएशन वैसे अगर प्लॉट करना चाहते हो तो वो तो जैसा जो ग्राफ आएगा वैसे प्लॉट करना पड़ेगा. ओके. सो if we saw CV, okay, CV upon temperature, okay, so in low temperature, okay, we are seeing this type of expression. So this is, if it is 2D material, okay, this is the energy, not CV. Okay, so CV it's proportional to T. So if it is 3D, you get CV equals to T cube type here, and here you have got constant. Okay, CV equals to 3R in 3D. Okay, in 2D you will get here CV equals to T square type. You get T square type here. Okay, instead of T square you get T, and here you get CV equals to 2R, high temperature region. In low temperature region you get here linear curve. Okay, CV proportional to T, and here you got CV equals to R. I hope you're getting what I'm saying.
Yes, sir.
Yes, sir.
Okay, thank you.